Well, hello. In this video, we're going to talk about special cases of system of equations. In this case, we're going to talk about substitution. What happens if we have substitution, if we're solving a system of equations by substitution, and we get one of the special cases? Now, just a quick review. Remember, when we're talking about systems of equations, there are three possible scenarios that could happen. We could have a line, or excuse me, two lines, where they intersect each other, and the intersection point is the one solution. But another scenario is we could have the two lines that are parallel to each other, in which case there would be no solution because they don't go and intersect. Remember, the solution to a system of equations is the intersection point, and if parallel lines don't intersect, there's no solutions because they are parallel lines. And our third scenario, of course, is we have one line and the other line is mapped on top of it because, in fact, it's the exact same line. It has a lot of intersection points. This is infinite solutions because they are the same line. So in the previous video, we talked about how to solve by substitution and get one solution. In this video, we're going to talk about what will it look like if it's no solution or infinite solutions. So let's do our first example here. Our first example here is going to be 6x plus 2y is equal to 3. And then we have 3x plus y is equal to negative 5. So if we're going to solve this by substitution, the first thing we need to do is get a variable by itself. Which variable here is the easiest to get by itself? One thing we talked about was positive and single, right? So top x, top y, bottom x, or bottom y. Hopefully you can see that this bottom y is the easiest to get by itself. Y is equal to negative 5, and I would have to subtract 3x to get it to the other side. So we got that bottom y by itself. And we're going to take this y and we're going to substitute it into the other equation. So we're going to have 6x plus 2, but we're going to substitute y is equal to 3. And what's going in for y? The negative 5 minus 3x. So distribute. You got 6x minus 10, because we're distributing, minus 6x equals 3. Then combine like terms. 6x minus 6x is, well, look at that. Those cancel each other out. They eliminate each other. They cancel. We're left with negative 10 is the only thing left on this side because these cancel, is equal to 3. Now here's the thing. Is that true or false? Is negative 10 equal to 3? That is certainly false. But here's what happened. Notice how when we substituted in, before we used to be able to solve for x, but in this case, the x is eliminated completely. In fact, both of our variables are gone, and we're left with a false statement. So guess what that means? That means this is no solution. If both variables eliminate and what remains is false, that is no solution because in the graph, the lines are parallel. Real quick, side note, this part you don't have to write if you don't want, but check this out. If I was to solve for y on this top, the bottom was y is equal to negative 5 minus 3x. But if I was to solve for y on top, it'd be 2y is equal to 3 minus 6x. And if I divide by 2 on both sides, I would have y is equal to 3 halves minus 3x. You see how both of these lines, they both have the same slope of negative 3, but they have different y-intercepts. But here's the thing. We don't have to solve for y in the top equation. I'm just showing you that these lines are indeed parallel. They have the same slope, but they have different y-intercepts. But here's the thing. If the variables eliminate and it's false, then it is no solution, parallel lines. Let's do another example. Our next example is going to be y is equal to 2x minus 4. And then we have negative 6x plus 3y is equal to negative 12. All right, so we have a variable by itself, so save us a little bit of work for step one. And we're going to take that and substitute that into the other y in the other equation, so it's going to be negative 6x plus 3 times, here's the thing, we're going to parentheses around y is equal to negative 12. What's going to go in for y? Well, what y is equal to up top. So it's going to be 2x minus 4. So solve, we're going to distribute. So you got negative 6x plus 6x minus 12 is equal to negative 12. Combine like terms, once again, look here. Our x's are going to cancel. Our x's are going to cancel and we're left with negative 12 is equal to negative 12. So once again, our variable is eliminated. However, in this case, the equation that remains is true. So if the variables eliminate and what remains is true, this is going to be, you guessed it, infinite solutions, because it turns out they are indeed the same line. Variables eliminated, but the remaining thing is true. They are the same line. In case you don't believe me, look here. Our original equation was y is equal to negative 2x minus 4. If I was to solve for y on this bottom one, I'm going to do it down here. I'm going to add the 6x, so negative 6x plus 3y is equal to 12, negative 12. Add 6x, you get 3y is equal to, I'm going to put the 6x first, minus 12. And then if I divide by 3 on both sides, I'm left with y is equal to 2x minus 6. Or, excuse me, 12 divided by 3 is not 6. 12 divided by 3 is 4. But look at this. This is the exact same line as the top equation there. Now again, guys, you don't have to do this part here. Don't worry about that. What I need you to know is that if the variables eliminate and it's true, it is infinite solutions, the same line. If the variables eliminate and it's false, that means it is no solution or parallel lines. So, in case you need it, this might be helpful for some of you. We'll make a little flow chart. First question that you should ask yourself is, do both variables eliminate or go away? If the answer is no, so like we're left with x, that means we're going to have x or a y. That means we're going to have one solution. And it's going to be an ordered pair as x, y. However, do both variables eliminate? Variables, pluralize your noun, Smith. If both variables do eliminate, then the next question that we have to ask is the remaining equation true? So, did both variables eliminate? Yes. Is the remaining equation true? If the answer to that is no, then that means there's going to be no solution or parallel lines. But both variables eliminate. Yes. Is the remaining equation true? If the answer to that is yes, then that means our final answer is going to be infinite solutions or same line. Right? So, if you're left with a variable, just solve it the way that we have it. It's going to be an ordered pair. However, if both variables eliminate, that is going to be a special case. And so, if it's false, it is no solution. If it is true, then it is infinite solutions or same line. How have you got questions? Smith out!